So, so for the first 20 years, do they just want us to write like first year, second year, third year, fourth year, etc.?
Uh, yeah. Is there an easy way, quick way to do it?
Um, is it where I had to like do the first and the last, and then the second last, the second and the second last?
Yeah. You also have a formula.
Oh, and E is equals to 5,000.
And
Or
D is 5,000. Yeah.
is this like, I don't know, like the n over 2 formula? Or
Yeah.
so n over 2 and then 2a plus n minus 1d.
Yeah.
And n will be the 20. No, no. Will n be just 20?
Yeah.
Okay. I'll put this into my calculator.
All right. Oops.
I got 1.35 million.
Times D, which is 5,000. That's what I'm getting. Did I do something wrong? 2a plus n minus 1d. Maybe I missed the second bracket, did I? Oh, I don't know. Let's see. 1,320. Is that what you got?
No.
1.32
Oh,
million?
5.
I got 1,345. Where did we go wrong here? Let's see. Year one, his profits are 20,000. He predicts his. Maybe A is 0, is it? No. A is 20,000. He predicts his profits increase. He predicts this will continue until he reaches profits of 100,000. He then uses his annual profits to. To remain at 100,000. Oh, that's weird. Oh, so how many years until he makes 100,000?
Um. So year 3 is 30,000. So I'm guessing will it be year 10?
Might be. So it'll be basically that formula is less than 100,000, or less than or equal to, and we have to find n. You could try different values for n.
So I still sub in A and D.
Yeah.
Okay.
So replacing that with x. 2 is 20,000. X minus 1. Common difference is 5,000. And that other equals 100,000. Does it take 4 years? Did I put that in wrong?
I got 1.4 for some reason.
Why are we so wrong about this?
I don't know.
It's totally wrong. What am I putting in wrong? I don't get it. Okay. Let's just, okay. 100,000. Take away the 20,000 he starts with, is it? No, even then. Let's just... let's just do it long way.
Okay.
Yeah. And then it'd be that over 5,000. So 80 over 5.
Is that 16?
So that's 16. So that means for the first 16 years, it works normally. And then for years 17, 18, 19, 20, it doesn't go up anymore. So what would it be if n was 16 in our formula?
Shall I solve it in all?
Yeah.
And make it equals. So just do the n is 16, and should I not have that equals to 100,000 thing?
No, just at 16.
Okay.
So first 16 years. Okay, so I got 920,000 I got. And then you just do 4 more years at 100,000 each.
Yeah.
What is that?
4. So do I just have to times that by 4 or?
No. So it says, so the other way it was like 20, 25, 30, 35.
Yeah.
And we're adding those up. Eventually it reaches 100,000 and just stops there.
Okay.
And they say, so for the last 4 years, so it took 16 years to reach 100,000. And so years 17, 18, 19, 20, it's 100,000 every year after that.
Okay.
And so you would add those on.
So am I adding 100,000 on every year? I'm a bit confused.
So for the final 4 years, he makes 100,000 every year.
Yeah.
And so you're adding those on.
100,000. Yeah.
And whatever way you want to do it.
Okay. And yeah, that's 1.32 million.
So 1.32 million. Okay. Terrible question. Why would... Yeah, okay. So part B, state one reason why this may not be a suitable model.
Because I don't know. Well, I know because we it just took like so long to find out, but
I think maybe just because, like, why would his profits stop increasing, or why would his profits go up by the same amount every year? Something like that.
Mm-hmm.
How would we do part C?
So do I need to do something like 20,000 times 20? No, times 1.05 to the power of 20.
Yeah. What is that?
And that would be 53,065.95.
53,000 and
65.
£95.
Yep.
And 1% is what? All right. Oh, hang on. You have to add them up. So that's just what he would get in the final year.
Oh, so is that plus the 1.32 million?
No. So for C, A is 100,000.
Yep.
What is N?
20.
And this time it is multiplied by something, and so it's R.
Oh, yeah, 'cause it's a common ratio.
Yeah.
So is that just 1.05?
Yeah. So what you got was year 20. We wanted the sum, like what they would all be added up. So do you remember that one?
Is that like something like AR to the N minus one or something like that?
Yeah.
Yeah. Over just N minus one.
I think it's R minus 1.
So,
So let's try it. Wait, whoa. A was 20,000, wasn't it? My mistake.
okay. I got an answer.
This one, 661319.
Oh no, sorry, I subbed in the wrong number once. So yeah, I got that. Yeah.
Let's see. And there it is down the bottom, 661319. So this time, so these are some formulas. So instead of, hang on. So question 1, terrible, absolutely terrible. They should have just said, for 16 years or just 20 years, and it just keeps going up. They just threw in that little extra thing that it stops making sense in year 16, and they even said in part B, state why it's not a suitable model. So big picture is you just have to recognize that the question is asking you to do a sum problem.
Yeah.
So the first one was the sum of an arithmetic sequence, and the third one was a sum of a geometric sequence, basically. Any questions there?
No.
Okay, and so you find N, find R, find A, and do it that way. I just want to see what this looks like. Okay, let's try this one.
Okay, so her common difference seems to be 5, and A is 10.
Yeah, and I'm just going to write it as write them in pence form, because I imagine the final answer might be pounds.
Yeah. And yeah, sorry. So and her A is 0.1. Yeah.
Okay. N.
Is that just how many 5p's it takes for
Nope.
until week 52? Oh no. Okay.
So what's N?
It's something to do with week 52, isn't it? Like where it stops.
I think it is 52.
Yeah.
So find the amount she saves in week 52. How do you do that?
Sub into the formula.
Yeah.
So that's like the N over 2 to A and minus 1 do.
Okay, try that.
Yeah.
Maybe we should have left it as pence.
I got £71.50.
Okay. £71.50. Let's see. That is £71.50. And that's technically question B. That's her total savings over the week. Sorry, over the year. Do you know what part A is? Just what she got in week 52. It's a much simpler formula. You might not remember it though.
Oh, will it be the last one, like the L? It's like L. I know, I forgot what it was, but I think it's called like L in it or something.
That's just the same formula written a different way.
I'm not sure then.
A plus n minus 1d.
Okay. Oh yeah. Okay.
If I remember correctly. Sorry. So tell me when you get an answer for that one.
Yeah, I got £2.65.
£2.65. £2. Oops. 65. £2.65 and £71.50. Yep. So these are just like the other questions we were doing, except they're kind of putting them for real world stuff. It's just called modeling. Any questions there?
No.
Okay. So what do you give yourself for those ones?
Nothing overall, I'd say.
Yeah, I don't want to spend a lot of time on it. There's other exam questions, but it's just the same idea. They just apply it to the real world. And that's it. Find A, find N, find D or R, and sub them into the correct formula. And you just have to recognize if it's arithmetic or geometric, and if it's a sequence or a series. So do they want term 52 or do they want to sum to 52 terms? Okay, binomial expansion. Do we recap this from year one? Maybe we better.
Is it just the same as year one or?
Nah, in that case, yeah. You think you're okay with binomial expansion from year one?
Yeah.
Okay, good. So now you have a different type of binomial expansion, and you use this when only when the magnitude of x is less than 1. So when x is between 1 and minus 1, basically when x is a fraction.
Okay.
You have to use a slightly different formula. And this is the formula, and I believe this formula is given to you. Let me just chuck it up here. And it can be derived from, like, if you sub a fraction into the normal formula, it won't work, but if you do it algebraically, you get this formula. So let's see, find the first 4 terms for this one. So n is 4. Let's see, that's the only thing you need. And the way you would write this would be 1 plus x to the minus 1. So what will this be if you sub it in here?
Into the so 1 plus am I just answering the question here? Or?
Yeah, actually I'm wrong about that n. N just starts with no, terrible. Where'd you go? Okay. This one. Expand using the binomial expansion thing. How do we begin these?
Do I start off by doing 8 cubed?
Yeah.
And then plus 3, and then NCR1.
What is N? What is R? So I would do, for the first one, HU0, 8 cubed, 20x to the 0.
Yeah.
Second one.
So is that not 8? So that's 8C0. Oh, because this is the first one. And then second one would be 8C1,
Yeah.
8 squared,
Yeah.
20x to the power of 1,
Yeah.
and 8C2, 8 to the power of 1, 20x squared.
Yeah.
And then the last one will just be 20x cubed. Right.
Yes.
Yeah.
Okay. And 20x cubed, and that works out. And that's what we get. Yes, this one, factorize each bracket separately. So this is the same thing, just written the long way. If you factorize each bracket, what would you get?
You would get like 4, and then 2 plus 5x.
2 plus 5x, and you would do that 3 times. And so how could you fully factorize then at the end?
You could then end up doing
And these are all times each other.
Yeah, so 64 times 2 plus 5x cubed.
Yeah, sure. Let's just say 4 cubed. And so, yeah, if you factorize 4 out, like if you have a bracket that's being expanded, you can, if they have a common factor, you can factorize that out and just put it to the same power.
Yeah.
Okay. Fully factorize. That's what we get in general. Okay. Oops. Let me just change color. That didn't work. That worked. Ooh, okay. There we go. 1 plus da 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 da. Use these first 4 terms to estimate the value of this. Any idea how you do this one?
Put it into my calculator.
Put what into your calculator?
Would I do 10 to the power of x over 2 equals to 1.005 to the power of 10, or I mean x over 2 to the power, is x over 2 to the power of 10 equals to 1.005 to the power of 10?
Yeah, or much simpler. Just this bit here, 1 plus x over 2 is equal to this bit here.
Oh yeah, yeah.
Yeah. And so use that to solve for x.
I got 0.01.
Looks good. And what would you do then?
It needs to be to 5 decimal places. So do I need to add like 2 zeros? Oh no, 3 zeros on or something?
You would. So x is 0.01. All of these x's you replace with 0.01.
Okay.
And okay, go on. Go for it. Put it in.
Yeah.
I'm just going to do 0.01 answer. And then 1 plus 5 answer. Squared. Do you have an answer?
Not yet.
I got one. So 1.05114.
Yeah.
And that's basically just sub in x. Let us now make some sense of this. We put into our calculator 1.005 to the power of 10. 0.005 to the power of 10. And we get a very similar number. So our estimate was 1.05114. The actual number is 1.05114, 0132 and lots more digits. It seems a bit crazy, but there's, I'm sure, a good maths reason for it. 1.005 to the power of 10. You would just put it in your calculator. In the old days, and for stuff you'll use later, you would do 1 plus x over 2 to the power of 10. X is 0.01, and then you would sub that into the expansion.
Okay.
And you'll notice that x is a fraction. Any questions there?
No.
Okay, weird stuff. Let's see this one. Yeah, that was it. Okay, what is this one?
So if I do 1 to the power of 5 and then half, do I need to do like 5 NCR, oh no, 10 NCR 5 and then times half times x to the power of 5?
Hang on. 1 plus, find the x to the 5th term. Oh, sorry. I just wrote the answer. So 10 choose 5, 1 to the power of 5, and a half x to the 5. And that's the one you get. Okay. You're already good for that. Okay, how would we do this one?
So do I need to do like 126 times 0.01 to the power of 5?
Yep. Yeah, that's fine. You've got the idea. Totally fine. So you can see here it's a tiny term.
Yeah.
And it wouldn't have affected our previous one, because our previous one was only to 5 decimal places or something. And so it's 1, 2, 3, 4, 5, and then the next two are like 0, 0, so it wouldn't change the rounding at all. Let's see. Yeah. Okay, how about this one?
So do I just sub in 0.01 for each term, or?
Yeah, so what would be 0.01 to the power of, let's say it's the power of 5.
That would be 1 times 10 to the power of minus 10 in standard form.
Yeah. What do you think what type of number would you get if it was to the power of 100?
Um,
Or what type of number is that one?
0.
Yeah, it's basically getting really tiny. So it gets, the bigger the number gets, or the bigger the power gets closer and closer to 0. Just like the one we saw a second ago. It was like, lots of zeros, like to 8 decimal places or something. How about if x was minus 0.1?
So if I did like minus 0.1 to the power of 5, that would be minus 1 over 100,000.
Okay. And if that was to the power of 100 or something?
It'd probably just be 0 again, wouldn't it?
Yeah. And
Yeah.
so any number that's in between 1 and minus 1, the higher the power, the closer it gets to 0. How about if x was 2? What's going to happen there? The higher the power goes.
So if x was 2, yeah, then wouldn't the numbers just carry on going up and up, basically?
Yeah. And if it was minus 3?
Yeah, they just keep on going down and down.
So I think it oscillates between like negative infinity and positive infinity. Like
Yeah.
if it's a even number, it will go to positive infinity. Odd number, negative infinity. Yeah. And so this is what the graphs look like. So if it's bigger than 1, then it goes to positive infinity. Or if it's smaller than minus 1, it goes to positive infinity. That's like x to the 10. But x to the 9, it's an odd number. So you can see how it's like negative infinity or positive infinity. Yeah, but basically in between 1 and minus 1, they get close to 0, the bigger the power gets. So basically we can derive the formula from the previous one, but in between 1 and minus 1, then if x is between 1 and minus 1, the bigger the power, the smaller it gets. And so for binomial expansion, that will that you only have to do it to a few places.
Yeah.
This one's gonna be fine. Or maybe we better do it. Okay. No, that's not. What would be question B?
So do I need to do minus 4x squared or something?
No, that's just another way of writing that.
Yeah.
And so we want magnitude of x.
All right, just minus a quarter and a quarter.
Yep. And yeah, so both arrows would switch to point to the right, but I just point them left and put the -1 on the left. And so if you put that back into the magnitude form,
And then so would it just be that magnitude of minus a quarter is smaller than?
just magnitude of x is less than a quarter.
Okay.
Just a different way of writing that.
Yep.
Okay. So now, all right, let's try this one. 1 plus 3x, sorry, 1 over 1 plus 3x to the 2, 1 plus 3x to the -2. If you put that into normal binomial expansion, you can't do like 3 choose -2. So we use this form of the formula instead. All right, sub in the values. What do we get?
So are both of those, they're not two separate questions, right?
I just wrote that this is the formula,
Yeah.
And I just wrote this one to the power of -2 instead of 1 over to the +2.
So n is -2.
So here it's like n is 0, n is 1, n is 2, n is 3.
Okay, so
I think. No. N is -2. Yeah, n is -2.
should I just sub in -2 for each bit where there's n here?
Yeah.
So 1 plus -2 ax, or
Wow.
even just -2 ax. Yeah.
What is A?
So it goes like ax to the n.
Yeah. So what is A?
A to the -2.
A is 3.
Right. So
Excuse me.
left 3.
Yeah.
3x. Yeah.
X. Yeah.
-2 and then brackets -2 -1
Mm-hmm.
over 2 factorial.
Yeah.
And then 3x squared.
Mm-hmm.
And finally plus -2 times -2 -1 times -2 -2.
Yeah, and I'll write it as -2, -3, -4. It's basically gone down by 1 each time.
Yeah. And over 3 factorial ax cubed.
What's A?
3x cubed.
That's it. Okay. So first term is 1. Second term.
Second term is -6x.
Yeah.
Is there like a factorial thing on my calculator?
Graphical, is it?
I've got graphical and I've got the other one.
So normal one is shift and x to the -1. So 2 shift factorial, yeah.
So the 2 factorial is just 2.
Yeah.
And so 6 divided by 2, so 3 times 3x squared. So will that be 27x squared altogether, that entire thing?
I'll just take a look. So -2 -3 3 squared all over 2 shift factorial. Let's just put the whole thing in without the x. And you get 27, yeah. So that's 27x squared. And so try the last one.
And so I'll just put all of that in without the x basically again.
Yeah, and you can put it all in the denominator. It's the same thing. You don't need to do it as a separate. Because a Binomial, it's exactly the same.
So I've got -108. So would it be -108x cubed?
-108x cubed. Looks good. So this is. Let's take a look. That's the working out. And then. I made a mistake. That should be x cubed. X squared is already there. 27x squared -6x is 1. So this is a lot like binomial expansion. It's exactly the same really, except it uses just a different form of the same formula and it's a way to handle negative powers of x, because you can't do like 3 choose minus 2, that type of thing. This is only valid for certain values of x. In this case, when the magnitude of 3x is less than 1. So basically it's a fraction. So what would that be for the magnitude of x?
Like a third or something.
Yeah, when the magnitude of x is less than a third. So these are only true when the magnitude of ax is less than 1. And in this case, when the magnitude of x is less than a third. So this expansion is valid if you used it for something like 0.1, like what we were looking at earlier, but it would be invalid if you used it for a bigger number like 2, something like that. And that's because those numbers go towards infinity, whereas these fractional numbers will go towards 0. So you'll eventually just be adding on plus 0, like those tiny, tiny little numbers. Any questions there?
No.
Right. Now we can go back to my exam questions and stuff, I believe. Okay, let's go back to this one. So we said n is minus 1. What else do we need? I think that was it, was it? Okay, so sub in values. What is this?
So find the first 4 terms in the binomial expansion of 1 over 1 plus x.
Yes. So we do it for 4 terms. Yeah, n is minus 1. Okay.
So 1 plus, or even 1 minus x.
Yeah.
And then plus minus 1 times minus 1 over 2 factorial.
Yeah. What have any idea what that is?
And then plus minus 1 times minus 1 times minus 1 minus 2 over 3 factorial x cubed.
Yeah. And did you find that factorial thing in your calculator?
No, sorry. When I do it, I usually just do it like the entire thing just like normally, and then I simplify it after the second row.
Oh, okay. Yeah. Sorry.
And then and then that'll be. Will that just be 1x squared then?
Yeah.
And yeah.
And then how about the x cubed?
So they've given us some sort of R value here.
No. Where are you seeing R? Oh, no. That's just like to the final term or something. Don't worry about that.
Okay. And so minus 1 times minus 1, and then sort of dot, and then minus 1 minus r plus 1 over r factorial x.
No. Ignore that.
Ignore that. Okay.
That's just in general. So first 4 terms. 1, 2, 3, 4. So the 4th term will have x cubed because technically the first term was x to the 0.
Oh, so that was it. Okay, fine. Sorry. And now, so we know that that's just x squared because we did it earlier. So I just need to find the fourth term, don't I?
Yeah.
And so that would be. I think that's just minus x cubed.
I think so. I think that's why they chose this one. Yes. And so, sorry, I thought you were struggling with it, but you're just showing you're working out by writing it down first. Is that what you were doing?
Yeah.
Yeah. That's perfect. That's what you should be doing. Sorry, I thought you were struggling or something. Yeah, great. Okay. Any questions?
No.
Got it. Find the expansion of that. It's the same. Yeah. Yeah. We'll do it in a second. Yeah. Okay. Oh, exam questions aren't messing around. Do I first find this thing? Shut it up to including the x cubed. Is this? Another way of writing this is 1 plus x, 1 minus 2x to the minus 1. Nah, let me go back. Skip it. So you're going to be fine with those. Let me think about this. Fine. Okay, well, there really is no two ways about it. You just got to jump in and do it. Yep. Okay, this one. Just expand the second bracket. 1 minus 2x to the minus 1. First 4 expansions for that one. And let me get the formula, which is given to you. There we go. Okay, so just expand the second bracket.
So, when you say expand, do you mean like the 1 minus 2x to the minus 1 bracket?
Yep. So what this is like binomial expansion is just a formula for expanding brackets.
Yeah.
And if it's to the power of a minus or a fraction, then you use this formula.
So 1 plus x and 1 plus 2x.
I don't know. Hang on. What is a? What is n? Yeah, 1 plus 2x. Yeah.
Oh, actually, because it's minus 2 to the power of minus 1, will it be minus a half?
I believe it is. So n is minus 1. Ax is minus 2x. Yeah, so it's plus 2x. Yep. Plus 2x is correct.
Okay. But isn't it minus 2x to the power of minus 1 rather than times minus 1?
So you can see here.
Yeah.
What is so 1 plus ax to the n? What is n in our one?
Minus 1.
What is a?
Minus 2.
Yeah. And so minus 1 minus 2x.
Yeah, okay. So plus 2x plus, and then minus 1 times minus 1 over 2 factorial, and then thing. And so a is minus 2, So it will just be minus 2x squared.
Yeah, and I'm just going to put the x squared on the outside actually, just so all that goes in the calculator later.
And then plus minus 2. Oh no. Minus 1 times minus 1 minus 1 times minus 1 minus 2 over to be factorial, and then times is it 2 cubed? Minus 2 cubed, sorry.
Minus 2 cubed, yeah.
And then
And that's the x cubed term. Okay, work them out.
so 1 plus 2x, yeah. And then do I need to make minus 2 squared?
That was my fault, yeah. That should be squared. Maybe I should leave the x inside.
And then I got plus 4x squared.
Squared. Okay.
And then I got 8x cubed plus 8x cubed.
8x cubed. So you expanded the second bracket, and now to expand these double brackets, you do the first bracket times the second bracket down here.
So 1 plus 2x plus 4x squared plus 8x cubed.
Yeah.
Plus x plus 2x squared plus 4x cubed plus 8x to the power of 4.
Yeah. Simplify.
Simplified, that would be 1 plus 3x plus 6x squared plus 12x cubed and plus 8x to the power of 4.
Yes, and actually, did they not ask us for it to the power of 4? Yeah, they only wanted the first. They only wanted it as far as the x cubed term, so we don't need the x to the 4 bit.
Okay.
X to the 4, but we did need to do every part of that because we needed to know that the x cubed one up here gave us 8x cubed, so we would have 8x to the 4 down here. That's part A done. Part B, for what range? Sorry, state the range of values for which of x for which the expansion is valid.
Is this where you do like magnitude of x?
Yeah.
Is smaller than. Do I need to do like 2 to the power of minus 1 or?
No.
Or minus 2 to the power?
The magnitude of ax is less than 1.
Okay.
What is a?
Minus 2.
So the magnitude of 2x has to be less than 1. And we want the magnitude of x.
So would it be the magnitude of x is smaller than minus a half?
No such thing exists. If it is smaller than positive a half.
Yeah, of course.
And if you write it out the long way, it'd be like minus 1, minus 2x, positive 1. If you divide everything by minus 2, you would get a half, and they'd point to the right, minus a half. But that's just the same way as saying x is between a half and minus a half.
Yeah.
That's it. Let's see. So we showed it, and then we got that bit. So This is full on, but let's see. Sub them into the formula that we have to use when we have the power of a minus. If it was the easy stuff, like if it was power of 2, power of 3, power of 4, we would just use our old formula, year 1 formula. If it's the power of a minus or the power of a fraction, we have to use this formula. And this time we had to expand 2 brackets. One of them was like this. And so we did the first 4 terms. And you could just keep going with more and more terms. They asked for the first 4 terms. And so we did the first 4 of the second bracket. And then you just times them by the first bracket. And you've got the expansion of those 2 brackets. And that's just a different way of writing that there. 1 plus x is like times 1 minus 2x and minus 1. Any questions about that?
No.
And if I can, no. Maybe let me just go back to what would be for question B the range of values for which x is valid?
So do I need to like 1 plus 4x to the minus 2, or
Yeah. For what range of values will our expansion be valid though?
will it be like so A is 4, isn't it?
Yeah.
And so would it be like x, no, if magnitude of x is smaller than a 16th?
No. A quarter.
Well, okay.
Let's see. Do I have any others that are similar? Probably not. Let's see. No. Yeah, for this one, for the bottom part, 1 plus 3x, state the values of x for which it is valid.
So A will be will A be minus 4? So will it just be magnitude of x is smaller than a quarter?
No. This is the question.
Yeah. So do I need to do like 1 plus 3x to the power of minus 1?
Yeah.
And so will it be magnitude of x is smaller than a third?
Yes, well done.
Okay, cool.
Great. Brilliant. Yes. How was that for you, Andrey?
Apart from that magnitude thing, I thought everything was pretty good, yeah.
That magnitude thing is supposed to be the easiest part. The other thing is supposed to be the difficult part. Will we continue this next time?
Yes, please.
Okay. Any questions for me in general? All right. Well done, Andrey. You did great. I look forward to trying again next time.
Thank you. Bye.
Goodbye.